We're going to talk to you today about using new technology for maximum construction efficiency. So we're going to look at an introduction to BIM, why we should use it, and some practical applications, and then think about the future. So I'm going to be flipping between a few hats during the session. I'm a director of a BIM management company. I also developed an app for use on construction projects, and I also help implement a program called Revizto. So we'll kind of flip between these three things as we go. What does BIM mean? It means building information modeling. So it's basically, if we look at the next slide here, there's been an evolution over decades from a hand drafting process through to CAD, where a lot of you are aware of CAD files, where basically you're drawing 2D drawing, but in a program, so it's very, very accurate, to now building information modeling, where you have a three-dimensional model and all the data is attached to the objects in those models, and the drawings are created from the same models. So my company, Virtual Built Technology, have been involved in developing 3D models like this so that companies can basically virtualize what they're going to build, and then they can see any problems that might come up. They can look at things like the services, how they're going to be coordinated, things like construction equipment, how it's going to fit in, cranes, and basically perceive all these problems and solve them before you get out on site. That's the idea behind it anyway. And it opens up a lot of possibilities, things around like analysis. You can check for solar analysis and structural analysis, and a lot of things can be automated. As I mentioned, there's a lot of information now attached to these 3D models. So a single structural beam, might have lots and lots of different bits of information, to do with its strength and what Rio is in there, and how long that beam is, and all this kind of stuff is all attached into the model automatically. And that can then be used for a lot of things, for projects from a small size to a really large size, because you can then see what you plan to build. There's no kind of hiding. Even things like progress payments, we can check how much concrete has been installed, and then that affects your actual payments you're giving out to your subbies. So there's a lot of terminology that gets thrown around, and I don't want to get bogged down in all of this, but the industry has invented all these different terms to try and describe BIM and how it's used. So this one's one of the crazier things, I think, is they've invented terms beyond 3D to 4D, which is essentially planning out your program of your construction. 5D, which is related to cost. 6D is what they basically refer to for sustainability, and 7D for facility management applications. So it's, I didn't invent these terms, it's just what the industry is using. Another one is called LODs, which are a level of development. So a 3D model, they're not all created equally. Some are highly detailed and some are really, really generic and basic. So LOD 100 is a really generic thing that doesn't have much detail. And like LOD 400 and 500 is when you've got a model that's really accurate, like it's got how big each piece of duct is and the flanges, and all the detail for fabrication is all in those models. So different projects have different levels of detail. The actual BIM models are used in a whole heap of different ways, right from the kind of concept of a project right through, as we mentioned, all those different stages, right through to when you're going to renovate, because now you've got a highly developed 3D model that you can reuse for life cycle analysis, essentially, on that building. So why is there this push on BIM? It's been probably decades in the making. It's really because of the potential cost savings and time savings that it can come about, because you can do things like lean construction, which is where only the kind of materials that you need are arriving at site at the right time. You're not having waste. Prefabrication, where you build something in a factory before you even install it on site. So these things are really transforming the industry because they have a direct impact on time, cost and quality. There's a number of challenges that come along with that because you've now got very big teams who are working in these 3D modeling spaces. And so they're having to essentially transform the way that they're thinking about construction. One of the most obvious uses for BIM is services coordination. And again, this applies right from small projects to large ones, because if you develop your 3D model enough, you can essentially see problems that are going to happen before they happen. Now, on the left here, this is what we don't want to happen, where you've got a little piece of cable tray, and instead of kind of designing this properly, let's cut out a structural member and then put the cable tray through. Incredibly bad thing to do. Or over here, where you've got a drawing that kind of has a line for the call-out view, but then someone on site thought that means that's how we're going to form up the concrete. So they've got the concrete wrong. So this is why we want to look at things in 3D in detail first. And there's a direct impact on cost, because if you do have a clash on site, you've got to pull things down, you've got to take them to the tip, you've got to remanufacture things, and the cost can be like in the millions for large projects if you haven't done this services coordination. And the industry is starting to use tools on site, like the iPad, to actually facilitate this. So they're taking the iPad out on site with their model, with their drawings, and then they're able to take photos and do things in this digital space. So if we want to be efficient as a construction team, we need information. We need it at our fingertips. It needs to be accurate and as live as possible. We all love kind of an old car, but they didn't give us as much detail into what's going on with that vehicle. What's breaking down? What do I need to do to fix it, to maintain it? So same goes with our construction sites. There's newer methods of gathering information that are going to let us really solve problems before they happen. So we're going to have a bit of a look now at the software tool called Revizto. It includes the ability to view drawings and view the model, and also what we call reality capture. Laser scans and photos on site are able to be viewed inside that platform as well. And you can compare like the model that you're holding in your hand against the real world behind and see if things are actually developing as they should. You can scan in plant rooms and load them into this environment. So let's have a look at the actual tool. I'm going to switch over here now to this project, which is a Revizto project. It's not a very large one. It's kind of a 2 or 3 story, so it kind of fits in between that, small residential and your high-rise kind of stage. And let's have a look at the capabilities. So we've got a 3D model which we can navigate really easily and smoothly. I'm using the computer right now to do this, mouse and my keyboard. We can select an object in here, and if we go to look at the properties, we can see all of the data attached to that object. As we said before, this is BIM, right? So it's not just something we can look at. We can actually see the information related to every piece of equipment in this entire model. We can also begin breaking down this model into its parts. So it's what we call a federated model, which means that multiple trades have been merged together into this one file. So we'll have things like a structural steel model, plumbing, electrical, and we can colorize the model based on those trades. And now in this particular view, I can see, like in light blue, for example, my plumber's model, in pink is my mechanical model, and in the green is like my electrician, and of course the red is the fire. So we're seeing all this merged in together. And we could kind of view it with the architecture loaded up, and we could do some kind of walkthroughs, like we're walking through at a particular level. We can now look up, and I've just made the ceiling transparent, so we can begin to see, what's going to happen at first fix, what's happening at second fix, which trade is going in first. And the whole concept is that we can not just see things in this environment, but we can then begin raising what we call issues. So if we see something that looks really wrong, like it can't be installed that way, there's going to be a significant issue with it, then we can raise an issue. And we use what we call stamps for that. So looking up here, perhaps there's some problem with what I'm looking at on the screen. So I click on the stamp icon, and we have a number of kind of typical issues that might happen on a project, right from the design stage when we're dealing with an architect, through to like clashes when we're dealing with like a subby team that's generating models, and then things like safety in design and sustainability. So different types of issues that we're going to see. So let's say this is a electrical design issue to do with these lights. So I click on the model there, and in that one click, we've raised an issue. And it's going to appear in an issue list, and it's going to be assigned. We can assign it on. Let's assign it to Peter Johnson. So he's going to get notified of this issue, and we can then begin marking it up. So I can use the sketch tool here, and I could begin perhaps marking up that perhaps this light needs to be deleted. We can use leaders and various shapes to mark up on here. Now, once we are in the issue tracker, I'll show you the issue tracker here. We've essentially got a list of all of the current actions on our project. And what we're trying to do again is look for problems before we get to site. Or we could be on site and utilizing these same tools. So we've got our electrical design issue. We can have a comment thread about it. So we could put in some notes, please delete light. And essentially that issue will go through a few steps. It'll be in progress when Peter's working on it. Once he's actioned it, it'll be marked as solved. And then there's a jump from solve to close, which usually a manager type person handles. We can see that it's detected automatically what level it's on, what room it exists in, so we can use that for reporting. We've got a snapshot view here, which we can edit, or we can go look at the 3D model and kind of navigate around, see what else is happening around that area. Or we can click on 2D, which takes us to our drawings. So the same kind of environment now has drawings loaded into it. And there's a few things we can do with this. Firstly, we can look at the drawings. We also see that some things kind of have this blue highlight to it. So if I click on that, it actually takes me to the drawing directly. So I don't have to kind of deal with a big stack of A1 sheets or something. I just click on those between those different views to go to the right views. And then if I want to view this particular piece of the drawing overlaid on the model, I just click on this scissors icon here. And now I can see the actual drawing overlaid directly where it sits in that 3D model space. So we can see how the drawing and the BIM model relate to each other. I can move that section back and forth here. We can see things, like how the flashing ties in with the structure. That orange color is the actual fabrication steel model, so it's highly accurate about what's going to be installed. We can see that certain things like maybe the architect, he put in a larger zone for this head member than is actually needed. So we can begin comparing against, the proposed design and the actual, 3D model that's going to be installed. And again, from anywhere here, we can click on that new issue button, drop our issue pin and begin marking up to take an action. Now, what the platform also allows is us to then jump into the 3D model at this location back in the program that created it. So you may have heard of the program Revit. That's usually used for creating 3D models like this. So I can right click here and go to switchback. That's going to open up Revit and it's going to put me in this location, and I can then do some 3D modeling work. So we're simplifying the feedback between reviewing things and actually fixing them back in the model. So looking at the 2D side again, we've had a look at a section view overlay there, but we could take this entire floor plate and click the same scissors icon, and we're now overlaying the architectural drawing for the entire kind of site there, and we can have a look at how it relates to the in-ceiling space, to the subfloor, and we can see all of the relationships. And what we're really looking for is things the architect might have missed or not, maybe not gotten right. So if we look at this particular case, you can see that the architect has proposed, maybe a floor waste over here between the basin and the toilet, whereas the plumber has put in kind of two wastes. And so, really what the architect proposed has kind of been expanded on by this subcontractor team, and we could again raise an issue here. We've picked up something, it's a problem, we're going to assign it on to somebody to action it. So that's the issue tracker. The idea between this 3D viewer is that you can't break it. It's easy to use. Even for, we've trained Sparkies, walking around on site, they're not technical people, but we've trained them to use this platform because it's really a simple interface. And so if I click on the map view here, I can see where I am in the context of the whole project. If I click on the sectioning icon, I can then basically cut through my entire model and begin looking at things like in from the side here. So we've got our service disciplines, we've got our architectural model, and then, as we said before, we can apply like a color profile to this to quickly identify which service is which, so that I know, who to call if something's not right, or raise an issue, assign it to them. Here's kind of a classic case here. We've got the bit of mechanical work that's actually clashing completely with plumbing and electrical. It simply cannot be installed like this. We've detected it in the model, so we're going to raise a clash. It's let's say a mechanical clash. We click there and we've raised the issue there directly on the element. Make sure it's assigned to the correct person. We'll assign this to Vlad, and then he'll be able to come in and action it. All right, so that's all kind of looking at it on the PC side of things. Feel free to jump in with any questions too. Anything that comes up as we go, happy to talk about it. But what I wanted to show you now was how we can do a very similar thing with the iPad. So let me see if I can get this showing up correctly for you. So you can see the iPad. Actually, I'll just hold it up. All right, so you can see on the screen, I'm projecting the iPad, onto the screen, and I'm kind of going to use my fingers now to control the iPad. So again, talking about how simple it is. Okay, so I've got my two thumbs on the screen. One of those thumbs is kind of turning, so I'm looking around, and the other one, as I click and drag it, is going to begin moving me through the model. So it's no more complicated than that. It's just this two thumb control. And I can then do the same things we were looking at before, like sectioning. So I can make a new section plane, double tap on a wall or something, and now I've cut through that wall. I can move my section plane through to see all the things that we're going to build. With the iPad as well, you have what's called movement control. So at the bottom left here, I'm going to tap this little icon. Instead of having to use my thumbs to control, I'm just moving the iPad around here to just navigate. Now, the idea of the iPad is we're walking around on site, we're looking at something in the model, which is how it's intended to be built, but then we see something that hasn't been installed as we expected it to. So we go and grab a stamp, and it could be a defect. And in this case, maybe it's a mechanical defect, and it's to do with the air conditioner. So tap on the air conditioner. So we've raised an issue now using the iPad. And what I want to do is I want to attach a photo directly to it. So I'm now using the iPad camera. I can see an air conditioner there. Take the photo. We use the photo, and I can even use the pencil there and just touch screen, mark up on that. I could make a note. And if you've got an internet connection on your iPad, you can even use the dictation. So you could go mechanical problem with air conditioner. So I haven't had to type that out. Just got the note there coming up because I've dictated to the iPad. So I click done and send, and so that photo has then been attached to the comment thread. So we've now got the location of the issue, the photo from that issue is all loaded up, If I wanted to go, I could go to the issue tracker. Again, as I said before, we could go to 2D. If I tap on 2D, I can look at any drawing that shows me that location. So maybe the ceiling plan, hit select, and I can see on my ceiling plan exactly what room that's in and the location of that issue. And same with 2D, we can raise issues directly on the 2D space. So I could go grab a stamp. Maybe this is a safety issue and something to do with the balustrade or something. So I tap on the drawing there and then go and do my markup, and I'm just touching there on the drawing to mark it up. We can adjust all of this and click done. Now that issue was raised on a drawing, just like you might mark up a PDF, but the system's smart enough to know where it is in the real world. So I can then just click on 3D, and now it's put me in the 3D model at that spot where I, proposing a balustrade or a temporary railing or something needs to go in. So the 2D and the 3D worlds are all interconnected. Now, what this particular builder used this for on this project was he raised up a heap of defects. So he's now using this tool to manage his subby team, which are, concreters, painters, etc. So if we go to like concrete defects, he has taken all these kind of actions. What he's done, he's just gone to his drawing, he's tapped on the drawing when he's seen a problem, and then he's immediately taken a picture. So in this case here, we've got the location of the issue. If I tap on the photo, he's held up his tape measure there, he's taken a picture of it. We can see there's a riser problem, it's a concrete defect. That's going to basically get emailed as a report to Mr. Concreter. He's going to see a list of stuff that he needs to fix, and then he's going to use this to jump in and action it and feed that back to the builder. So even for very small residential scale things, this application is kind of useful where, we're not writing things down, we're not marking up on drawings anymore, we're using a digital version of the project to drop little pins and mark them up and manage the team. And so they've done this for all their trades, brickwork, blockwork, cladding. So we just filter those. You can see cladding defects that they've seen. Tap on that. He's not happy with this caulking here. So he's taken the photo and he's raised it up to the team. In addition, we can load in what's called 360 photographs. A 360 camera is very small. It's about the size of your normal smartphone. They're very cheap. They're about $400 or $500. And they take a spherical image of like a room space. So we can load in these 360 photos, and when we kind of view it here on the iPad, we can then just touch the screen here. It's not really linked to the 3D model, but it's letting us navigate around a 360 photograph just like we were standing there on site. So you can send one of your staff members through just taking photos through a building every day or something, and now you've got progress of what's going on site, how much did we install, what's still left, and then you can virtually review it later from somewhere else. So that's the 360 photos, so they're quite powerful and easy to use as well. All right, so I've kind of given you a good overview of what that Revizto tool can do, and that's just one example of kind of a mobile application that you'd use out on site. The other thing that it allows is clash detection. So I don't know if you're aware of clash detection, but when we've got a set of models like this and we've merged them together, we could look at them with our eyeballs and try and find a problem. That's going to take a long time. So wouldn't it be better if we could get the machine to do that? So that's what we call clash automation. So on this project, I've taken all my steel models and I've done a clash detection against all my other models. And now I can view across the entire site where there's any clashes. And that's completely, automatic, essentially. So it's showing me, ductwork here, clashing with steel. It could be a problem. And as we go through, we can see all these. And they're actually grouped together into kind of chunks that we can then assign to somebody. So you see these? You can see quite clearly here the kind of slot for the pipe doesn't match where the pipe's coming down. So, the model's not coordinated. But yeah, these are grouped together into kind of an area thing. And what we do then is we can mark it as reviewed, and then we can send it to the issue tracker. So essentially we automatically detect clashes. We send them through to the issue tracker, and then it gets assigned to the right person who's going to action it. We can see there the status of that issue. As a person begins working on it, it becomes in progress, it gets solved eventually, and we can then manage our models, making sure that this team is actually solving the clashes that's been assigned to them. And we can report on all of those things. So there's reports and dashboards that are included. So if I want to, I can open up our kind of web interface here, and we can look at charts of kind of the progress of the project. So we'll look at dashboards, defects. How many open defects do I have? 45, but I've closed 2,700 on the project. How do they break down by trade? All of these are kind of trade codes, so we can see how many, open issues by trade. See which project manager I need to get on the phone to or hold a payment on or something like that. So that's the dashboard side of things. It makes it easy for even a non-technical person to get a quick idea on the health of the project. So that's the clash automation. Now the final little piece here of the puzzle is, what if we want to quantify the model somehow? That's one of the real useful things, I guess, in BIM, is that, what if I want to count how many doors I've got? So I select one door here. I can look at the properties of my door, but I want to select all my doors. So I'm going to go and grab this property here, category doors. I'm going to go find the same, and it's found 493 doors. I could isolate those to see them all, and then I could look at like a tabular view here of all of the information to do with the doors. Now, it's kind of not showing me exactly what I want to see, because what's interesting about doors is like their width, right? So I should add the width and the height to my favorites. This is the door quantities, let's say. And so now I've got a list of doors plus their widths. Some other things that might be interesting is what level is the door on, because I need to buy my level 1 things before I buy my level 2 things. And maybe even, is there a fire rating, value of some kind? Is it a fire door or not? So I could bring that property through. So once we've got that information in this list, we could export it out to like an Excel file, and then we can essentially use that in our ordering process, talk to our door manufacturer or whatever. So I'll just bring the Excel over for you here. And, with Excel, we could do things like make a pivot chart on a new worksheet. I want to see doors by width maybe, and height, and if it's a fire door or not, and what layer it's on. So I can kind of start to see these things breaking down now, at first floor, the widths, the heights of my doors, and then like the count of how many I've got. So this has become, straight away a kind of an ordering list for my doors, by floor. Right, so that's a good look at Revizto. A fair bit to take in there. But again, it's just one example of how technology is now getting used on site and on big projects and small projects. So I've talked through most of the things that Revizto can do here. From the model, 2D drawings, mobile access, and so on. And we've had a look at a good kind of demonstration there of that. Now, the other tool we were going to briefly mention is called Deep Space. So with all this information that's floating around through the models, how do you work with it? You know, so much information in there. It's like almost too much to deal with. So you need to find ways to distill it down to something that is useful. And that's what we designed the Deep Space platform to do. Just for your everyday kind of builder. He's got all this new information getting thrown at him in the form of models. And we kind of propose using Deep Space as a way to distill that down and look at it in dashboards and so on. So this is a quick demo video. Don't know if the sound's coming through or not. But yeah, all the activities on site are now being tracked by various tools. You know, the crane movement, the installation of steel. So Deep Space allows us to export the data straight from, in this case, the Revit model, then begin using it for our construction, getting the maximum efficiency. And that comes in the form of dashboards, usually. So like visual dashboard, that kind of anybody can understand. I'll show you a couple of examples of those. If we just flick through. Next slide. So quantification, tracking, and then checking the model's actually good quality. In this case here, was a New Zealand project, lots and lots of steel, and broken up into 6 buildings. And so they wanted to be able to track their total tonnage of steel versus how much was delivered and how much was installed. And so we designed this dashboard for them. It's a very, very simple view, but it's collecting data out of all the models, as well as information that people are recording about, you know, this delivery's arrived on site, this piece of steel's been stood on site, and then it's filtering it all up. So like a project manager just sees this view, and really what it should tell him is, you know, building F, every bit of steel that we've got, we've pretty much stood, whereas building C, we haven't. So we've got to move our steel fabrication guys over to building C and get this bit done. So it's helping them to actually move their people around and get the job done. Quantification side of things, basically getting our quantities. It's trying to summarize it as simple as it can. So just giving us the lengths, the areas, the volumes, perhaps by level, the different categories of the model, and also looks at model quality. Now, when you've got 3D models happening, as I said before, they're not all created equally. It's a garbage in, garbage out type situation. So if these guys making the 3D models are not doing a good job, you're not going to get as much value out of it. So that's why we essentially automatically check those models for problems. So what's the future look like when you look at all these technologies to do with BIM? Companies now using this kind of technology to do prefabrication. So they fully design in 3D, a module. They build it all in a factory somewhere it's got a roof over the top. You're not going to be weather affected. You get all your trades in at exactly, the amount of time they need. They're not standing around waiting on site. And then you just deliver that module and then you plug it together like a big Meccano set. So that's kind of the future. Not many building companies are getting there yet. You might have seen, though, that you can now kind of buy tiny houses and that from China that essentially use this idea where everything's prefabricated and you drop it on your site at home and you just fold it out and tie it together with some bolts and it's pretty much built. The other kind of push in the industry is towards more reality capture. So that's things like laser scanning and drone photography. So looking at this here, we want to understand how much soil's been moved, because the contractor is going to send us a claim for 60%, whatever, of his soil movement. Whereas we've got a drone flying over every day, we can just have a look and see, oh, look, he's only done 40%. So we're not going to pay him that much. So they're actually using it to check, what people are asking for, making sure that things are happening as they're supposed to. And also digital safety is becoming more and more a hot topic. on these big sites. So what's next? You know, you've probably heard about a lot of these things, but you know, virtual reality is used a lot now in construction. You can put on the goggles. We've got some here in our office, and you can walk through that building. The difference with virtual reality is it feels like, you know, you're there. You're not looking at a screen. It's like you can put your head up above the ceiling in the access panel, look around it, and it's like a real world scale. So that's quite powerful. And then we've got laser scanning, Internet of Things. So that's when you've got all of the lights and everything's connected through to the internet, and you can monitor your electrical loads. You know, so that's becoming more and more common, as well as robotics and 3D printing. So that's you know, pretty much the content I had prepared. If there's any questions about any of that we've gone over.